record. Okay, we're recording homework review for number 10 for Thursday, October 8th class. So 42 is a piecewise function, x squared and 2x. You have to find the derivatives of these for x less than 1 and x greater than 1. And then find the limit as x approaches 1 from the left of this derivative and 1 from the right of that derivative. So if we think about it, x less than 1, that's a function that goes with it. And we did this in, I think, the notes. F prime of x equals x squared if f of x, sorry, f prime of x equals 2x, my bad, equals 2x if f of x is x squared. I think we may have done that already in the notes, but if you actually are curious, you know, you're going to be doing this, right? F of x plus h minus f of x over h, the limit as h approaches 0. If you actually go through those motions and plug in x plus h and x squared, and then they have x squared then, and kind of work all out, you will get 2x when you take the limit as h approaches 0. For b, so now when x is greater than 1, let me do a different color here. When x is greater than 1, that's our function. Well, f prime of x is going to equal 2 if f of x equals 2x. That's because it's linear. 2x is simply a linear function. The slope is 2 everywhere, and a derivative is the slope of a tangent line. So it's just 2. We actually talked about that in the 3.1 notes, that if you have a linear function, the derivative is just going to be the slope of that linear function, which is 2. So A and B should be hopefully not too bad. Now for C and D, because you already have the derivative expressions, right, you're taking the limit of all this of 2x. You're taking the limit of 1 as x approaches 1 of 2x, which of course is 2. Here you're taking the limit as x approaches 1 of, so now you have to use this one now. Because remember here, x is approaching 1 from the left side, so you had to use the 2x. Here, x approaching 1 from the right side, so you had to use the 2. So let me actually clear that up again. If x is approaching 1 from the left side, that means you got to use this derivative. So if I take the limit as x approaches 1 of 2x, that's just 2. Here, x approaches 1 from the right side, so I have to use that interval. So that was 2. So taking the limit as x approaches 1 of 2, that's 2. So that's how you do C and D. Now, does the limit as x approaches 1 of f prime of x exist? Well, yes, because the LHC equals the RHD. But remember, this is still not quite the same thing as saying the limit as h approaches 0 this is truly how you find the derivative. So this right here it's not the same thing, and that's what the whole point of this exploration. It's really about h approaching 0, where h is a horizontal distance between your 2 points that eventually become the same point, and then you find the slope of the tangent line. So it's kind of showing you that even though they would have the same slopes on each side, it's really more about what we have to do over here. And this is, and really it's just the limit as x approaches 1 of f prime of x. So it's a little bit different. So let's find the left and right hand derivatives here. If you did the left hand derivative using the formal definition at x equals 1. Now remember, x equals 1 is included. So it kind of looks like this. And y equals 2x. Now this is kind of interesting, to 2x. So see what's happening here. Is this continuous? Not continuous. Hence, it's not differentiable, even though, you know, if we did find the limit as x approaches 1 of this, you know, as x approaches 1 from the left side, we got a slope of 2 here. Now we got a slope of 2 here. Because they're not continuous, they're not going to be differentiable. So yes, the limit would exist for the derivative as x approaches 1, but it's not the same thing as the true definition of a derivative. So if I find my left-hand derivative, it's just like what we did before. You know, we just kind of work it all out. You know, you do like f of 1 plus h minus f of 1 all over h. Remember, you got to plug this in the x squared and work it all out. If you do that correctly, you know, you have like 1 plus h squared minus 1 all over h. If you do it all correctly, you should get 2. Now, if I do the right-hand derivative, you're doing f of 1 plus h. And by the way, this is 0 from the left. So f of 1 plus h still satisfies that inequality because h is a small negative number. If I do the limit as h approaches 0 from the right of f of 1 plus h minus f of 1 all over h. Now f of 1 I know is 1. f1 plus h. Now 1 plus h is a little bit bigger than 1, right? So now I got to use this one here. So I have 2 times 1 plus h over h and take that limit. So I get 2 plus 2h minus 1 over h, or basically I get 1 plus h, 1 plus 2h over h. The problem is I'm not going to be able to find that limit. Because if I plug in 0, I get 1 over 0. Or if I plug in like very small positive numbers for h, essentially this is going to go towards positive infinity. Plus graphically, if I were to try to connect these two, that's what would happen. So the left right-hand derivatives don't exist, therefore f prime 1 does not exist. So this is to kind of telling us that if you're not continuous, you're not going to be differentiable, because clearly is not continuous. So that's what's happening there for that one. Okay, we still have about 7 more minutes. Any other questions regarding the homework that you guys like to ask? And I'm more happy to go over some more problems. Or we could also do an early lunch break too. Fine either way. Okay, so hopefully, you know, we're getting a little bit better understanding differentiability. Like, so again, just because you're continuous does not mean you're differentiable, but you do need to have continuous functions for differentiability to happen. So when you are differentiable, definitely continuity is there, and a lack of continuity would also imply lack of differentiability. So I will do some video stuff on this in the afternoon. I will also have Google Form that goes with it, and I also have some textbook problems that goes with it. Also on the horizon, we do have a quiz on the 14th, which will be kind of like from the beginning of 3.1, where here's a function, find me the derivative using the limit definition of a derivative, and then maybe find me the equation of tangent line and normal line. If you have extended time, don't worry. We'll reserve the last 30 minutes of class on the 14th for the quiz. Quiz will be designed to only last 15 minutes for recommended time. So if you get 50%, 100% extended time, you'll be fine. And of course, if you finish early, you could always just get a head start on homework or ask me questions if you have questions about homework. That was due that day. We'll have a test on the 27th. So we are going to start 3.3 on the 14th. We'll continue that on the 20th. And then the 22nd, the Thursday before our test, we'll do just a bunch of review. I'll try to have some review stuff up on the worksheets. We'll probably work through worksheet 9, I think, and maybe worksheet 10 on next Monday, and some of the worksheets we'll kind of work through. Yeah, I think that's what we'll do. And then in November, we'll kind of continue our focus on derivatives and just kind of see where the world takes us. Lots going to happen next month with the pandemic and the election and whatnot. But I we'll still be here doing school, regardless, one way or another. Okay, well, if there aren't any questions, you guys feel free to sign off. We'll just end a little early today. If you want to stick around, I'm probably going to mosey on to Homer to pick up my lunch. But anyway, have a great weekend. I'll see you guys actually on Monday. So we'll see you guys a little bit sooner than usual. All right, see ya.
Thank you, Mr. Omashny.
Yep.
Thank you.